idea of cradle to grave with regards to a product, that's the way we used to behave. You know, you buy a car, you're good for 3 years, and you junk it and get a new car.
Right.
Why? Because it was designed to disintegrate within 4 years.
Engineered obsolescence.
Got it. So that you would buy a new car.
Yeah.
They didn't realize that you could make more money maintaining the same car over a lifespan of 10 or 12 years. You would have bought 3 cars in that time.
Yeah.
And then people rebelled against the idea, and then Europe began to produce, and Japan began to produce cars that lasted a lot longer, required less maintenance, pollution in the environment went down, and then BMW had the remarkable temerity to want to buy your car back when you're finished with it. Now, in a car, how many moving parts do you think there are? Lots, right? But I bet you I can tell you there are more non-moving parts in a car than there are moving parts.
There are more non-moving than moving, I'd agree.
Yeah,
Yes,
okay.
Absolutely, yeah.
So in a BMW that's assembly line manufactured,
Right.
they can disassemble the old car, get rid of the parts that are not worn out because they were moving, take the parts that aren't moving, they never wear out, and put them into a brand new car. You'll never know the difference.
Yeah, one of the first cradle-to-cradle, energy efficient and economically
So now
stimulating.
Volvo does it, Volkswagen, BMW. Why doesn't any U.S. manufacturer do it?
Right. What is it about us? I don't know.
Duh. That's all right. We'll eventually get.
We'll get there.
So those are the mantra for life on Earth. Cradle to cradle. You know, you're born, you live, you die, you're recycled.
Right.
Your atoms get dispersed back into the universe, and then they get recycled.
Right.
The atoms that we're composed of probably have traveled through hundreds of millions of different things before they got to us.
You could have calcium in your body that was in a stegosaurus. You could have, right?
Look at the CO2 we're breathing out all the time. Those were corn plants and, asparagus and cattle and all kinds of stuff.
That's why I love science, because science is a logical, I think it's, in many ways, science is a logical expression of what some people find in spirituality. It's a connectedness to everything,
there is
right?
a spirituality there.
Yeah, and many great scientists have
connected
that.
by the DNA of the organisms of Earth.
And I tell my students, trees don't produce oxygen. They recycle it. They fix the carbon.
In fact, they're getting rid of oxygen because it's a waste product.
Ah, look at that. Still have much to learn, Obi-Wan.
That's right. No, it's true.
I like that. It's an even better way to think about it. They're getting rid of it because it's their byproduct.
Life said, you're gonna eat that?
Yeah.
Oh, you're not gonna eat that? Okay, I'll take it.
All right, and then here come us. Yeah, here come the heterotrophs, the breathers.
Right. Exactly right. So teaching those simple lessons, those are simple lessons. Right? They're easy to teach. That's what I wanted to do in our School of Public Health. So we began this course called Medical Ecology to teach you what goes wrong when you screw that up.
Right.
What happens? Skin cancer rates go up, asthma rates go up, all kinds of things when you disturb the environment.
All the diseases.
Right. So they, about halfway through, said, we're getting very depressed.
Yeah.
We know you're telling us the truth, but we would like to work on something more positive than just sitting here listening to doom and gloom. So, and I wasn't presenting it as doom and gloom, but they were interpreting it as doom and gloom.
Right.
So I said,
these are medical pre-med students, presumably.
No, there were a bunch of different
Ivy League.
There were
mix.
7 of them.
Okay.
Some want to go into planning, some want to go into public health, some of them want to go to dental school, some
So diverse,
school. Very diverse. They all had one common goal, and that was to understand more about their environment so they could do something positive. Doing something positive is often very difficult. A man who planted trees, it's a little bit of a stretch. Get a bunch of acorns and start planting. You can do it, but that takes a while, and it takes perseverance, and it takes the right environment. That's not what's needed around here. We don't need more trees in this area necessarily, although if you look around, you can see a lot of trees, right?
And I would actually want more, but
And we love looking at this view because that looks like a forest in the back of us.
Let's take a look. And we're in Fort Lee, New Jersey.
We are in Fort Lee, New Jersey. The Fort Lee High School is right over there.
And here you see the George Washington Bridge.
That's right. Now you look north.
You look north now. Look how gorgeous that is.
Trees.
Yeah.
Trees, and more trees.
Beautiful.
So we like that view because the contrast between the forest of skyscrapers and the forest of trees attracts people to it. Why? Because it's diverse.
Right.
And it's it's got a lot of interesting interstices to grow into and crawl back out of and get a perspective on your own life.
And you see both worlds. You see the
you do.
You know, you look at space, right? The scab of humanity, of all the concrete we've repurposed, and then you see the beauty of that's beautiful too. But you see the beauty of the trees and the environment. Yeah.
So they wanted to work on. I said, "What do you want to work on?"
Yeah.
And so, well, give us a week.
1 week.
So remember, they're paying a lot of money for this course.
Yeah.
I didn't even know how much. I don't want to know how much.
Yeah, right.
I know that I didn't get it.
Yeah, education's important, but watch out for student
someone
loans.
got that money.
Right.
And so they were going to devote the rest of their educational experience, in my course at least, to working on something that they felt was important, that had a positive twist.
Okay.
And when they came back, they said, we would like to see how many people we could feed in Manhattan by raising food on the roofs.
They said they'd like to see how many people they can feed in Manhattan by raising food on the roofs.
Correct.
Huh.
That was exactly what they said. So I said, great,
Yeah.
but you have to do the science.
Have to do the science.
So how many rooftops are there? How many acres does that represent? And what kind of food would you grow? And how would you distribute that to the people? But let's not worry about that part.
Okay.
Just X number of acres of rooftop farm.
Right.
How many calories of crop? And then how many people can you feed with that crop? So the most energetic crop that they could identify is rice.
Really?
Per
Rice?
bite.
Per bite. The most calorically dense. Okay.
Yeah. Even solid starch, basically. You break that down into sugar, that's all your energy.
Right.
So they worked for 7 weeks on this project. And they ended up with a report, which they gave to me. I was the student and they were the teacher.
Mm-hmm.
And they told us all the machinations that they went through. They went to the map room at the 42nd Street Library. They got out the maps of Manhattan. They had scale drawings of each rooftop.
Right.
No commercial buildings were permitted for this study. And they measured them, and then they accumulated the results, and then they said, rice is our most energetic crop.
Mm-hmm.
Here's how many acres, here's how much rice,
Mm-hmm.
here's how many people. 2% of Manhattan.
2% of Manhattan.
That's all they could feed.
Really?
That's all they could
With
feed.
just one level
One
rooftop.
crop.
One crop of rice.
Of rice.
The most highly
and all
dense. Yeah.
2%.
2%.
Now, you can imagine how disappointed they were. They were incredibly disappointed with their result, but they accepted it. So I said, there is honesty here. There is sincerity here.
Right.
There is science.
Right. A great scientist says,
You know what?
This is the truth. I'm not altering my results. Right.
Exactly right. Well, that's not always the case, though, is it?
Yeah, unfortunately. Yeah, I know.
So I have another expression that you can quote me on. Is
Yes.
Trust science. Trust science. Do not trust scientists. Yeah, it's a little bit funny, but it's a little bit sad, too.
Yeah, I know, because
there's a rich history of forgeries, Piltdown Man, Cro-Magnon, all these crazy iterations of... There was even somebody who was trying to prove spontaneous generation of life. So the Pasteur Institute had a meteor, and someone put a seed in it. And said, the seed? Life is coming. So Pasteur says, oh yeah? Watch this. So he took a flask with a long neck on it, right? And he put bacterial media inside the flask, boiled it, and then with a Bunsen burner, he twisted the neck of the flask to make a U shape.
Right.
So this flask, there's no way that the air can go all the way into the flask, but it's open to the outside.
Right.
And his question was, if spontaneous generation of life occurs, and we know that if I just put bacteria in this fluid, it will turn cloudy overnight. Let's see how long it takes for the bacteria to spring up spontaneously. You can go to the Pasteur Institute today. That flask is sitting in a cabinet that's sealed off.
Flask.
It's the same flask. Nothing is in the flask except the medium.
And this proves that there is no such thing as spontaneous generation, of course. And as far as I'm curious, what was it? The density of the air and its ability, or the temperature, to not be able to float up or down that wouldn't allow it to go in?
It was the path of the air.
Path of the air.
It was a narrow tube.
Yeah.
And it did not allow for the convection of the air to go all the way through. So there was no way for a bacteria to go all the way in.
Gotcha. Okay.
So he was clever in his design.
Yeah, very clever.
But everyone agreed that it was open at the end.
Right.
Didn't seal it off. So okay, come on, life.
Yeah, let's go.
Let's get going here.
Yeah.
There was another guy by the name of Reddy, R-E-D-I,
Right.
who preceded him. He was a 16th century scientist. You know what he invented?
Tell us.
The scientific controller.
Reddy invented the scientific
He
control.
did. If you do something to one thing and you want to know whether it does something or not, don't do it to the other thing.
Right, we talk about this. It's one of the basic principles of
course.
science, right? You have to have a control group and an
You must.
experimental.
So Reddy is the guy credited with coming up with that. And as a result, he also contributed to the disproving of the spontaneous generation. All right, so back to the story.
Right, back to the story.
No, okay, this is the last day of class. We have a bunch of disappointed students in front of you. You're the teacher. What are you going to tell them? Go read a book? You know, max out your credit cards and have a good time because it's not worth it.
It's all over.
It's finished. Or you can build on the idea. Right. So I was somewhat desperate for a positive twist on their disappointing result.
Yeah.
And so I said, this is not a quote, but it's about it. So that's a great idea. You guys did a lot of work. You really put yourself into it. You exhibited huge amounts of passion and dedication. They did a lot more work than the class hours required.
Right.
Because they really wanted to get at this answer.
And because you were able to activate them and get them engaged.
It was their question.
Right. It was
Not
their
my
question.
question.
It was their. You let them
Ownership.
That's what I tell students. Own your
Ownership.
education. Find a YouTube that explains things to you.
Got it.
Own your education. Own
Got
it.
it.
No one's
So
going to
they-
teach you better than you.
So guess what?
Yeah.
At the end, I said, okay, that's a good idea. It's not a great idea. All right? Now, to make it better, you have to increase the area. And the only way I can see of doing that is to take your crop and move it inside the building. I would have never thought of that if they hadn't done their project, ever. But that's, you know, your cell phone is better than my cell phone, is better than their cell phone, is better than their cell phone. Why? Because I take a look at yours and I say, yours can't do this and you can't do that. Mine can do, I wish mine could do both of these things. I'll be back.
Right,
Next thing you know, you got a cell phone. Here, you can keep my other one. Now I have a new one. It's smaller, it's better. Let me have your cell phone now.
Yeah. And think about collaboration.
I want to show you something. You're not going to believe this.
Go
You will
ahead.
not believe this.
Right, go ahead.
No, I'm not going to play with it. I'm just going to show it to you this way.
Yeah.
There is now a device for sequencing DNA this big.
Which used to be
As big as a refrigerator.
this big.
It's now this big. You can sequence DNA anywhere in the world.
Cotton swab, some sort of ability to get that red somehow.
You get
Bam.
an insect, you get a bacteria, you get a plant, you get a person.
Yeah, what company makes this, and how can we get one donated?
Well, yeah, right,
Yeah.
exactly
That'd be
right.
great
I think
for-
eventually everyone will have their own.
Yeah, that's amazing. Wow.
So that's how far this idea has come since 1958, I believe, when Watson and Crick first published their results.
And I think it's important to note the female scientist, Rosalind Franklin, who I just want to be a complete gung ho, love your woman and your daughters here and your mothers. She made massive.
Without her contribution, they would have never guessed the structure of DNA.
There you go. And to the best of my knowledge, Franson and Watson, Crick and Watson broke in and illegally took some of her files, or no.
Someone showed them the picture.
Ah, so her work spawned their genius, sort of thing.
Correct. So that's one good idea, spontaneously generating another better idea.
Yeah, and I think about
the tragedy was that Max Perutz, the guy who was in charge of both Watson and Crick's work, did not recognize Rosalind Franklin's contribution.
Rosalind Franklin. DNA, Rosalind Franklin.
It's all right. There's a whole book on her now. You can read all about it, and the story is out.
Right.
And it makes these people look horrible because of what they did to her.
Right.
And what do you think she died from? She died from cancer. Why? Because she was doing X-ray crystallography.
X-ray crystal.
She was exposing herself to X-rays the whole time she was
Just
working.
like Marie Curie, right? And her husband slept with the uranium.
Precisely.
Yeah.
Okay, so back to the other story.
Back to the story.
Here we are with an idea now. In my mind, they've graduated. They're gone.
We're done.
So now what? So my wife and I, she worked in Midtown and I worked at Columbia, which is right across that bridge.
Right.
So at the medical center. So I would drive her to work,
Right.
and we would speculate almost every day as to which buildings would be appropriate for a vertical farm.
Oh, wow.
Oh, because what the students said afterwards was, wow, you can take crops and move them inside a building? I said, of course you can.
Right.
And they looked at me, wow, that's great. Of course, inside I said, geez, I hope I'm right.
Right.
I didn't actually know that you could do that. But I was pretty sure that greenhouse technology would allow for this to happen.
Right.
Okay, so, and in fact it has.
This is year 1999, 2000.
So every year I offered the same course, and the word got back to the next year's class, you should take this course because you get to do half of the course in what you want to do. Right? Doesn't matter what it is, you're in control.
And it's amazingly even more rigorous, more connected to reality, more all the heavy lifting curriculum content.
So here's my book.
Yeah.
And in the back of the book, are their names.
Class
Every
2007,
class.
class 2008, 2004. Look at that. Look at that.
And look at you want a diversity list?
Yeah.
I can't pronounce half of those names.
Right. Truly diverse.
They're from other places and
other
other
countries,
cultures.
other cultures, other.
And every one of them took this course and not one dropped out. Not one thought it was a horrible idea.
Yeah.
But I said, stay. If you think it's a horrible idea, stay and tell us why.
Look at that, right?
You have to say why.
Right, learn from the people who have vehement disagreements with you so you can make it more powerful.
Nobody did disagree. They started to think about different ways of applying it to different cultures, different situations. One that I loved the most was a guy from Japan. He says, you build a vertical farm in Japan, we have a lot of earthquakes. He says, I know, my vertical farm will be a boat. And it will be under the water as much as above the water.
Oh, wow, buoyancy. Look at that. Genius.
So you can exclude sunlight and you can raise crops that don't require sunlight, like mushrooms.
Yeah. Right.
And as it turns out, it's a fabulous idea, actually.
Yeah.
It's a remarkably great idea.
And you can transport it.
You can capture the difference in temperature between the upper ocean and the lower ocean and generate electricity.
Because if we're talking temperature change, we're talking ion moving, we're talking electricity.
And a fluid moving, right? Because it's in a closed tube.
Right.
So the colder part sinks and the hotter part pushes.
Colder part sinks and the hotter part pushes up. And
it's a U-tube. So if the fluid moves, it can generate electricity by turning a turbine.
Turning a turbine, and you turn the turbine, you excite electrons, boom.
And so you've got a self-powered boat to run the grow lights under the water.
Genius. And the grow lights, which of course will mimic the sun, the proper wavelength of sun. I mean, in my classroom I have full spectrum lights. All of it.
So that happened over a 10-year period. So at the 11th year I wrote this book. I'm not teaching the course anymore at Columbia because I'm retired.
Okay.
So